The Haber process, feeding the world, fueling war. This is the story of how one invention changed everything. Before Haber, fertilizer was scarce. The main sources, niter and guano, couldn't keep up with demand. Fritz Haber developed a way to pull nitrogen from the air and turn it into ammonia. Today, the Haber process produces over 100 million tons of nitrogen fertilizer every year, feeding nearly half the planet. But Haber also pioneered chemical warfare. The same discovery that saved lives also took them. Marie Curie was the first woman to win a Nobel Prize, and the first person ever to win 2 Nobel Prizes in different sciences. In 1903, she won the Nobel Prize in Physics for her work on radioactivity. Then in 1911, she won the Nobel Prize in Chemistry for discovering polonium and radium. During World War I, she invented mobile X-ray units to help doctors see injuries. What if one person revolutionized chemistry and fought for world peace? Meet Linus Pauling. He is one of the greatest scientists of all time, the only person to win 2 unshared Nobel Prizes. As a founder of quantum chemistry and molecular biology, he pioneered orbital hybridization and the electronegativity scale. His work enabled the discovery of the alpha helix and beta sheet protein structures, paving the way for understanding DNA. But Pauling didn't stop there. Influenced by his wife, Ava Helen, he passionately advocated against nuclear weapons. His efforts contributed to the Limited Test Ban Treaty. Pauling's book Vitamin C and the Common Cold sparked a public frenzy. He believed megadoses of vitamin C could prevent or treat colds and even cancer. Though rejected by mainstream science, his ideas remain a topic of debate. A brilliant scientist and controversial advocate, Pauling left a lasting impact on both science and society. Was he a visionary ahead of his time, or a brilliant mind led astray? You decide. Imagine a world without antibiotics or understanding diabetes. That was the world before Dorothy Hodgkin, the woman who saw molecules. Hodgkin pioneered X-ray crystallography, a technique where shining light through crystals reveals their atomic structure. This led to breakthroughs in understanding penicillin, vitamin B12, and after 35 years of work, insulin. Her work saves countless lives and laid the foundation for modern drug discovery. Before we understood life's very origins, there was Manfred Eigen. Drafted into World War II as a teenager, he would later win the Nobel Prize. Eigen developed methods to measure reactions occurring in mere nanoseconds. This unlocked our understanding of quasi-species and the era catastrophe in evolution. From war draft to Nobel laureate, Eigen's impact resonates in evolutionary biotechnology today. Meet Ilya Prigogine, the scientist who found beauty in chaos. He won a Nobel Prize for revealing how order arises from disorder. Prigogine's early life was marked by revolution and instability. His family fled Russia, an experience that shaped his view of the world. He challenged classical thermodynamics, introducing the concept of dissipative structures, systems that create order by dissipating energy. Think of a hurricane, a self-organized system fueled by energy dissipation, or the Belousov-Zhabotinsky reaction with its striking patterns. Prigogine's work has broad implications, showing us the universe is a dynamic, ever-evolving system. The ozone layer, a shield protecting Earth from harmful ultraviolet radiation. But since the late 1970s, we observed something alarming: ozone depletion, a steady lowering of ozone in the atmosphere. The culprits: manufactured chemicals, especially chlorofluorocarbons, also known as CFCs, used in refrigerants and aerosols. Thankfully, the Montreal Protocol, an international treaty, was established to phase out these substances. Because of this, the ozone layer is projected to regenerate completely by 2045. Imagine seeing a chemical reaction happen in real time. Ahmed Zewail made that possible, changing our understanding of the world. Born in a small Egyptian city, Zewail's journey began far from Caltech. He earned chemistry degrees from Alexandria University. Zewail pioneered femtochemistry, studying reactions in femtoscons. He filmed molecules in action using ultra-fast lasers. His work earned him the 1999 Nobel Prize in Chemistry, making him the first Egyptian and Arab to win a Nobel in science. Ahmed Zewail's work continues to inspire scientists. His legacy impacts medicine and materials science. CRISPR, a revolutionary gene editing tool, originates from a natural defense mechanism used by bacteria against viruses. The CRISPR system utilizes a guide RNA to pinpoint a specific DNA sequence. An enzyme called Cas9 then cuts the DNA at that exact location. Once the DNA is cut, the cell's inherent repair mechanisms activate. Scientists can manipulate this process to introduce new genetic information. Emmanuel Charpentier and Jennifer Doudna were awarded the 2020 Nobel Prize in Chemistry for their groundbreaking work on CRISPR. Their discovery paved the way for numerous applications. CRISPR holds tremendous potential for treating diseases, enhancing agriculture, and deepening our understanding of life itself. However, it also raises significant ethical considerations regarding gene editing and its possible consequences. Click chemistry is like snapping Lego bricks together, but at the molecular level. It is a chemical synthesis approach emphasizing speed and simplicity. The most famous example is the copper-catalyzed azide-alkyne cycloaddition. Developed by Nobel laureate Carolyn Bertazzi, bioorthogonal chemistry happens inside living systems without disrupting them. Copper-free click chemistry avoids toxicity and is crucial for biological applications. Comment below if we missed anything. Like and subscribe for more videos like this. See you in the next one.